Good morning and thanks for joining today's webinar. My name is Shona Bradshaw. I'm delighted to be joined by Matt Walmsley from our partner Vectra, who are going to be looking and taking you through this morning some of the ways in which artificial intelligence and machine learning can help ease your role as a cybersecurity analyst and investigator in hunting down cyber attacks fast. So just to give you a bit of an overview of the today's session, I'll give a very brief bites introduction before I introduce Matt, who'll be taking you through the crux of today's presentation. He'll be talking around why automation and artificial intelligence has become increasingly critical and useful in the life of the analyst, talk to you some methods around easing the cyber analyst workload, and also how you can use AI and machine learning to investigate incidents faster, getting to that root cause. Bit of housekeeping for today's session. Attendee lines will be on mute throughout today's presentation, but please do take the opportunity to post questions via the chat or the questions box, and I will pop back on at the end of the webinar to pose those to Dave. We will be looking at strategy and solution for today's session. We won't be getting into detail on any particular commercials, though of course those conversations are more than welcome via your Bytes account manager at the end. Today's session is being recorded, and we do have a feedback survey at the end, so do ask that you take a minute or two to request to put that through, so that you can, give us your feedback in terms of what's worked and what's not on today's session. So, who are Bytes? We are the security specialist reseller within the Bytes Allied Electronics Group, and we were bought by Bytes about 6 years ago, and what we've aimed to do ever since is to marry up the expertise, insight and the specialism that you would expect from the smallest specialist partner with the resources that come from being part of a global group. We work across the full spectrum of information security, from the next generation firewall and security intelligence through to attack detection, mobile, cloud, etc. And across all of these, we really pride ourselves on the technology capability and the delivery that we provide, whether that's via in-house project scoping, market and technology updates, accredited installation services, or support of any other technologies that we offer. So what are we talking to people about today? So it's increasingly being reported in the press that there have never been more security alerts and more things that security analysts and security teams are asked to address in order to find the needle in the needle stack. So essentially find that threat from all the other potential threats that could be out there. What we're talking to people about today is how machine learning and how artificial intelligence can make that task easier, reducing both the risk of the threats that are out there, the speed to detect when things hit the actual network and actually lock down the the threats much faster. And this session is designed to provide that insight. So it is around how we can understand latest tools and strategies that you have at your disposal, or you can have at your disposal, to make your role in finding the needle in the needle stack so much easier. So with all that remains for me to do is to introduce Matt from Vectra. We've been working with Vectra for about a year now. They are really pioneering the use of artificial intelligence and machine learning in threat hunting, under the recognition really that humans are not alone, not in terms of aliens descending from space, but there are technologies out there that can take away many of the mundane tasks that get in the way of actually adding value within the business, and that's something that the AI is doing. They're a rapidly growing solution. A lot of different companies are looking at artificial intelligence and threat hunting right now, and this session is designed to show you why, show you how you can leverage these types of technologies yourself, give you some insights into the tools and tactics that you potentially could use back at base, and also demonstrate the actual platform and how it works to help you pinpoint threats. So without further ado, what I'm going to do is change over to Matt now. I'll go on mute for the rest of the presentation, and I'll pop back on at the end to ask Matt all of your burning questions. Many thanks. Over to Matt.
Shona, good morning.
Good morning.
Just give me a second.
Not a problem. I will go on mute when I see that you're all set up. You're perfectly loud and clear to me, the audience.
That's good. I'm joining you from Dubai today. I'm over over in the Middle East. So it's a pleasure to be with you. So thank you for hosting the session. Hopefully you can see my screen. Very quick introduction. My name's Matt. My name's Matt. I'm one of the directors over at Vectra. Vectra is an 8-year-old, very high growth, very fast growing AI specialist company. And we've built a AI-based threat detection and incident response platform. What I'd like to do on the webinar today is really cover 3 topics. The headline of this webinar was around AI, so I think we should just get on the same page about, what are we calling AI, and maybe just give you a little taste of some of the different types of techniques we can use in machine learning to help you understand and maybe cut through some of the noise out there. There's a lot of hype around AI. Then I want to tell you a story about how Vectra has applied AI in the pursuit of detecting threat actors inside the network and improving the lives of those of you involved in incident response. And then just leave you with some information about, where you can find out more about AI and Vectra and sort of next steps. So sort of 3 parts to what I'll present today. But we'll start with AI. And AI, is nothing new. AI is a term that was first talked about, probably in the 1950s, and we can go back even earlier than that to, even to the pre-war days, where they were trying to figure out whether mathematics could take on problems and solve them in human-like ways. And AI really is when a machine or when a piece of technology seems to behave in a way that we would expect an intelligent, system to do so. So it's really, trying to program the ability to learn and reason in a human-like way. So do machines think? No, they're pieces of silicon with, voltages and ons and offs, but they can mimic and, show traits that make us, think that they're behaving in such a way. Now, AI, has been with us in our lives and used for many years too. If we go back to the 1980s, expert systems are a form of, good old AI, as we call it. But more recently, we've seen not only the conceptual development in academia, but the actual application of algorithms which actually adapt and change based upon the inputs they have. And this is really what machine learning is. So we can say that machine learning is a subset of artificial intelligence, and it's about adaptive software. We used to write software that said, that took an input, applied a static, process, and then gave you an output. Well, here we've got in machine learning a process where it's the input and the output are defined, but it's the software that's changing in the middle and adaptive. And then we can even drill down beyond machine learning and talk about something, a subset of that, which is deep learning. And deep learning is a way of mimicking some of the biological structures that we have in our brain. So, neural networks, neurons, synapses, and provide very, very adaptive systems that can not only adapt based upon the inputs they receive, but I can actually tune or select which parts of the input they act upon. And we'll drill down in all of those. Also, when we think about machine learning, we have to think about how those machine learning systems are trained. Right? It's certainly when we get into cybersecurity, it's not just a mathematical big data problem. We need to understand the threat actors, the behaviors that they're going to look for. So I want you to think about 2 types of training methodologies, or how the data is processed. And the first is when we know the task that we want the software to do. So in the context of cybersecurity, that might be a threat behavior that is global in nature. The threat behavior would manifest itself in a similar way regardless of where you are. So that's a kind of task driven. But we may have problems that we just want to throw raw data at the algorithm and let it figure it out to look for anomalies, look for clusters, what's similar, what's dissimilar. So data driven. So when we want to go for task driven, we use techniques to train or select the data So select the what we call the features. Think of those as the attributes within the data, the features, but that features is the correct term. And we as the data scientists, the person building the machine learning system, select the attributes, select the features, and then feed that data into the algorithm so it can learn and adapt. So we call this a supervised learning model. So there's no such thing as a supervised algorithm, but there is a supervised learning model. So supervised and unsupervised is about how we select the bits of the data we want to process and and training it. So we have supervised models. Now supervised models are usually very, very accurate because they're task driven. They're looking to do a particular thing. In the context of cybersecurity, that might be spotting illicit command and control signals going through an encrypted HTTPS tunnel. Okay, so that's a real, so we know exactly what we're looking for. Go and find the things that behave like this, and away it goes. But there could be things that are local in nature that we want to surface. So let's think about rogue admin behavior, or understanding reconnaissance, spotting rogue reconnaissance behavior. So we need to understand the local context, and here unsupervised models could be useful. So supervised and unsupervised is about how we train the machine learning. It doesn't tell you what algorithm they're using underneath. So examples, random forest or support vector machines, they can be used in a unsupervised or a supervised way. K-means clustering, which is as the name suggests, a way of finding clusters, can be used in an unsupervised manner and just thrown the raw data at it. So in supervised learning, it's all about extracting the features and selecting them, and then using that supervised learning probably in two ways, right? The first way is to have the supervised models classify something, predict a label. What is this thing I'm showing the algorithm? Is it good? Is it bad? Is it command and control? What kind of C2 is it? Is it data exfiltration? What is it? What am I looking at? Or we could use it for what the mathematicians call regression. And regression is to do with predicting a quantity. And in fact, in Vectra, in our Cognito platform, we use supervised learning for both classification and regression tasks, classifying threat behaviors, predicting a risk level or a certainty level. So we use classification and regression. So if I was a data scientist and I wanted to build a supervised learning model to find out predict the number of people that are going to buy a hamburger, I would have to extract certain features from the data set I've got. So their hunger level, how much money they've got, probably their geographic location, maybe their demographic, right? All those things to build a model. So the data scientist is doing the feature extraction, selecting the algorithm type, and then building the model to either do a classification task or a regression task. But there are some things where we just throw the data at them, and we call this unsupervised learning. So unsupervised learning, you just throw the raw data. There's no pre-selection of attributes or features. There's no pre-training of it. And what unsupervised learning is generally used around is clustering, trying to find out, is there a group of here? Is there a group there? Who looks similar? Who looks different? And clustering's all over our lives, right? When we go online, we're clustered, we're profiled, and that's how digital advertising works. What's the demographic? Where are you connecting from? Where have you previously been? So unsupervised learning models are very good at just working through unstructured data or raw data without any human intervention in terms of design, but they are typically a little noisier. So we use Vectra, we'll use unsupervised learning approaches when we're just trying to learn things that we could never know in advance. Your IP address range, your network topology, your administration behaviors. They're not global in nature. So we'll use unsupervised learning for that. And then more recently, we're increasingly deploying deep learning. Now, deep learning, as I said at the start, mimics the neural structures that we have inside our brain. Very, very, very deep networks. So you can see the data coming in, you can see the data going out, and to be honest, what's happening in the middle, you don't have insight to. So there's a certain opaqueness here which is one of the challenges with AI, is trying to understand and, how did it come to this decision? So, deep learning is very computational intensive. So we use it judiciously, and in fact, some of our data scientists are very, very good at building economic deep learning models. But the nice thing about deep learning is that once those neural networks have formed, we can transfer them and use them elsewhere. So we can train up in a task and use that as a starting point for a second model, and away we go. Deep learning also has an element of what we call reinforcement. So you think of reinforcement as a feedback loop, weighting of decisions or particular synapses or parts of the network. Think of it as adding a bias or a weighting or a reward. The electrochemical processes in our brain, have reward mechanisms. We do something and we feel good about it, and down at a biological level, there's a reward, signal that reinforces stuff. So you can see that's used in deep learning. Now, these techniques are no better and no worse than each other. It's a case of really using them appropriately in the right place. But just to help you understand, or maybe contrast traditional, or what I would call traditional machine learning versus deep learning, is this, if we wanted to build a model to identify cars, using a traditional supervised machine learning approach, we'd need to do the feature extraction from the data set. So we need a data scientist to look at the raw data and say, okay, these are the attributes that I'm going to pass into my machine learning algorithm, which I've designed, right, to decide if this is a car or it's not a car. Now, in a deep learning model, we can have the model itself decide which, or go find the data features to do that classification, because it has that feedback loop, right? So when it makes a car not car decision, there's a feedback loop saying, yeah, you're right, that's a car. Well, no, that's not a car. And it will, through an iterative process, learn and get better and better and better. So if you're a data scientist, it's about choosing the right tool for the right task. There's no free lunches out there. There's no one size fits all. Each algorithm will solve a different problem, has its strengths and weaknesses. Each learning methodology has its strengths and weaknesses, and it's about judiciously applying and building the right algorithms for the right task. And that's a job that our data scientists do at Vectra. So let me now look at, so now we've got kind of a foundation of some of the vernacular around AI. Let's look at how we can apply AI in the pursuit of threat detection. And I want to start with two kind of problem statements, because these are fundamental to the reason Vectra was formed. The first problem that we want to solve is the fact that today, when a threat actor gains post-penetration, once they've entered the network, once they've defeated or bypassed security controls, defensive measures, it takes way too long before we find them. If we look at the M-Trends report for 2018, the median was 101 days to find an attacker once they have gained a foothold inside the organization. And in almost 50% of the incidents, we only find out about the attacker because an external party tells us. So that usually tells us there's actually been a full-blown data breach at that point, or maybe some overt denial of service. So 101 days, that's over 3 months. Yet a good attacker can probably get the keys to your Active Directory domain in a matter of 2 or 3 days. So there's an inordinate amount of time where attackers have, the run of the mill. And the reality is, defense are imperfect. There's no perfect defense. And in fact, you get diminishing returns. Now, of course, we might be able to keep 92% of the threats at bay with defensive measures, but something will always get through. Just read the headlines. We know it, right? There's no perfect defenses out there. And in fact, you get a diminishing return on your defenses as you deploy more and more and more. And so what we're seeing is a fundamental mindset shift to this almost compromised mindset, where we realize that, I am compromised as an organization, and my job as a cybersecurity professional is to find those, indicators of compromise early, so I can intervene before this becomes a full-blown breach and I've got, a GDPR headache or what have you. And so we're seeing a a move to defending where we can, but be ready to detect and respond, and have a far more agile and adaptive security architecture. So time is the thing that we can help with AI. We are time poor as a profession, right? And we are underinvested in spotting active attacks inside our organizations. AI can dramatically shrink that detection gap. And the other thing is, we're not only time poor, we're overworked. There's a massive talent and human resource gap inside our profession, right? Which is great if for us as individuals, but actually for organizations wanting to protect their business, their customers, their data, and reduce their risk, it's really hard to hire and retain talent. And when you have that talent, you and I working in our roles, a lot of the stuff we're doing is mundane. By 2022, Frost & Sullivan are forecasting over 350 unfilled European cybersecurity jobs. There's a massive gap. So we're time poor and we don't have enough people. So the people that we have got, we need to help them be more effective. We need to take the weight off their back so they can get more done in their day. And this is a great opportunity, to use artificial intelligence, not to replace, but to augment, to supercharge, to help you achieve more in your working day. So what we've done at Vectra is apply machine learning to find the bad guys. Look for the threat actors inside the network, but use it using data science, using machine learning. So instead of trying to write an explicit signature, which means I already have to know exactly what the threat is, what it looks like, fingerprinting it, I'm going to take an approach which has much greater longevity. I'm going to consider, what does the threat look like in terms of how it behaves? What are the points that are common in all these threats that can identify them? And then, what can I learn locally over time? So here we have a behavioral approach, not a signature approach, which means that even if I've not seen the threat before, I've got a chance of spotting it based upon how it behaves. So what we've done at Vectra is really, we act at the interface between leading data scientists, and most of our ML team are PhD doctorate guys and girls. They're wickedly smart mathematicians, but they're not all cybersecurity experts. So we marry data science with some extremely competent and aggressive security research. So this is how we build an attacker behavior model. Our security starts with the security research, the subject matter expertise. We identify, prioritize, and characterize fundamental attacker behaviors that attackers must manifest in pursuit of their goals. We don't care what vulnerability, what exploit, what malware they're using to get in. We're going to find them by how they behave, right? And we validate those models, and then the data scientist teams go off and build the algorithms to do that. So we build these high fidelity detection models that look for the things the attackers must do without relying on signatures. So let's have an example. Let's think of a threat that's global in nature that would show up similar across all organizations. Let's take a RAT, a remote access Trojan, external remote access, we call it. Now, security researchers say, how does a remote access Trojan behave? What are the things that we would be able to spot? Well, you'd see the conversation, remote access, the orchestration of it. What we tend to see is the infected host generally initiates a call out to the RAT controller, and then you get instructions back. So there's a cadence, there's the timing, there's a volumetric thing, there's a frequency, as well as what's actually in the communications itself. And so the data scientists then take lots of examples of different remote access Trojans, and we train a model using a recurrent network. And so this model doesn't look for a particular rat, it looks for what we might call ratish behavior. And this rat detecting algorithm looks for any rat because it's identifying the features that are common with all rats. For example, when shadow brokers, which was the NSA dump of government, US government hacking tools came out, there was a 0-day rat. So a brand new remote access Trojan, which we believe the NSA had, that nobody had seen in the wild. And our rat algorithm found it straight away. We'd never seen this threat before, but we knew how it had to behave. It was a rat, so it has to behave like a rat. And that's how we spotted it. So using this behavioral approach helps us with global threats. Now, there could be things that are unique to the organization that we're trying to help. So let's think about credential misuse. So here, the security researcher thinks and has a hypothesis of around, well, okay, what would the attacker behavior look like for a stolen credential? So, we might see an authentication, maybe through Kerberos, right? We'd see different hosts, unusual hosts connecting and using the stolen credential, and then maybe moving laterally. Quite often we've identified, you see, remote procedural calls, RPC, going across there as well. So we take these hypotheses, we validate them. Is this really how it's playing out in life? Yeah, and then we go and build a detection model. Now this would be an unsupervised model in this case, because I'm looking to train based on purely local context. So I want to look at your learning your normal and abnormal services, controllers, looking at your RPC usage, the who, what, where, when of how your administrators behave. And those things come together, and we've built a number of models which are all about helping identify the misuse of credentials. Looking for suspicious Kerberos, looking for suspicious admin behavior, looking for suspicious remote execution. So different models, all in the pursuit of identifying the attackers based upon the behavior. And what we're doing here is really creating the opportunity to spot them, at multiple stages of the attack. So we can think about, let's say there's two general types of attack. There's the opportunistic, botnet, ransomware, things like that. And then we've got the more dangerous, I would suggest, targeted, where we've got an advanced attacker who's coming after your organization. They're going to, after post-infection, they're going to be looking to do reconnaissance behaviors, move laterally and privilege escalation, and then get to the end game, acquire data, manipulate data, delete data, or steal data. Each of those phases of the attack give us the chance to find them. And there's also relationships between them. So, if we see reconnaissance, then, what's the next move going to be? And this gives us a glimpse of predictive analytics. Okay, so if we know, if we've seen what's happened so far, predicting what the next move would be, and giving us a real chance to get ahead of the attack. So it takes us at Vector, probably about 4 months to build an algorithm, and just give you an idea of a workflow of how that runs through. It starts with the security researchers. They collect samples, they come up with hypotheses, they abstract the behavior and form a theory. They try and test that theory, and then they start working with the data scientists and collaborate to extract the appropriate features. If we're using a supervised model, test, validate, and then build the model and test it on live data. Review, feedback. Right, we've now got a model to a point where we're happy with its performance and its efficacy. Our product designers build it into the UI. We develop the user interface, and then we put it out into production and monitor its performance. Security, like anything else, is an iterative process. So we're always trying to beat ourselves, right? How do we make it even better? How do we make it use less CPU cycles? How do we make it run faster? How do I make it even less noisy, more effective? And so we push out new algorithms every month to our Vectra users inside their Cognito threat hunting platform, sometimes to find new attacker behaviors that we come up with, and sometimes improvement. So I've been with the business about 3.5 years. When I started, we didn't have any deep learning inside our product, because it was really hard, to build those models. And now we've done that. So, some of the remote access Trojan detections that we used to use, traditional supervised models for, we're starting to put deep learning in there now as well. All right. So all those things have come together to build, the product or the solution that you can get from Bytes. And this is a cyber detect and threat hunting platform called Cognito. And it has two parts. The first is called Cognito Detect. And this is a automated threat detection system that finds, those hidden attackers in real time inside your network, right? It can allow you to find them not in 101 days, but find them in minutes. So you can get in front of the attack, spot it early in its life cycle. And then more recently, we've added a capability we call recall, which is the ability to go back in time and look at what was happening across your network historically and do manual threat hunting. And this is a beautiful counterbalance to Detect. So Detect will provide the initial evidence and say, look, here's a host that's at risk, and then you can drill into recall to find out what else has gone on there. So it starts with the data, right? We talked a lot. I've probably used the word data science about 100 times already. It starts with the data, and the data for Cognito from Vectra is the network packets. The packets never lie. The raw network communications, not an interpretation of what's going on. It's the raw evidence across your network. And because we're network based, it means we don't have to burden the endpoints with any kind of client software. And that particularly helps us with things like IoT, where we've got devices that you simply can't put security software on, or mobile devices or visiting devices that you have no sort of span of management or control over. So we take the packets, we extract features from that data, and we use that extraction to find attacker behavior. When we find the attacker behavior, we have some regression going on. Remember, regression was trying to predict a quantity. We'll use regression techniques to do what we call detection scoring. So not only are we saying, oh, we found this behavior, we're going to score it in 2 dimensions of threat certainty and threat severity. So now I've found something, and the AI is also giving me its view on the risk level of that detection. But there's another piece of AI running here as well, and that AI is constantly trying to identify hosts and follow them and follow their history. And we know in IP networks that IP addresses alone are not a very good way of tracking hosts over time. With things like DHCP, mobile devices, my laptop might have a completely different IP address tomorrow, right? But I want to monitor it and understand the context and its behavior over time. So we have this host tracking AI, and what we do, we then correlate the individual attacker behaviors with their detection scoring back to a host. And the host then gets an aggregate host score of risk and certainty as well. So now, as a security analyst, I'm going to see the hosts with different security scores, and I'm going to be able to start to prioritize of what's going on. And then more recently, we remember that diagram about the kill chain or the different stages of the lifestyles of the attack. The AI is also going to correlate the behaviors across hosts. What we're doing here is building a picture of what we call a campaign. Which machines are involved in this attack? I may have a point of entry into your network, I've got a point of persistence, but then I've moved laterally, I've escalated my privileges, I've set up new services and done RPC calls. Who's involved in the attack? Show me the scope of the attack that the AI has found. So we have attacker campaigns as well. And this happens automatically and in real time. So now, as a security analyst, I've got this piece of software, my AI sidekick, if you like, Cognito, who's got my back, constantly looking at the network communications to surface attacker behavior, what machines they're on, and who else is involved in that. Okay, and here's just an example of some of the different attacker algorithms that we have, and you'll see the different colors shows the different steps in the life cycle, and each line is a particular attacker behavior. Again, completely agnostic to the software, the vulnerability, the exploit, the tooling that's in use. It's the behaviors. So we have around 50 different algorithms now that are going to spot C2, recon, lateral movement, privilege escalation, data manipulation and exfiltration, and botnet, ransomware, cryptocurrency mining, and all things like that as well. So we've got multiple. What this shows us is we've got multiple opportunities to find the attacker as they progress through these behaviors. Our goal is not to find everything the attacker does. Our goal is to how quickly and how accurately, without putting all that noise out there, can we find the attacker and surface it to you so you can make an intervention. So really what we're doing is using the behaviors that these attackers must do think of them as almost like silent tripwires for the attackers. And we're focusing on particular attacker behavior, not just anomalies. Yeah, just because it's unusual doesn't make it bad. People get up to a lot of weird stuff on networks, doesn't make them bad, it just makes them crazy, unusual, weird. So unusual does not equal bad. Unusual just means it's a statistical outlier. So anomaly detection by itself is a massively noisy way of trying to find things of interest in terms of cyber attackers. So that's why we use that behavioral approach. We focus on what the attacker must do, not what it is, but what it does, right? This behavioral model of attacker behavior. And if we use a behavioral model, and don't have to concern ourselves about the what it is, we don't have to look inside the payload or of the packet. And that has, if I'm candid, an unintended consequence, but which is really powerful. We are seeing a massive amount of encrypted traffic inside not only internet connections, but increasing inside our private networks as well. And even if the communications are encrypted, we can still monitor how those communication flows are behaving. So even if I'm doing command and control or data exfil through encrypted channels, we'll spot it. Now, we might not be able, well, we can't tell you what's inside the packet, but we can tell you that the threat actor is there and something's going on, so you can run to the fire and make an intervention. So this behavioral approach is really powerful for increasingly encrypted networks. Now, what we can see here is the homepage, the host page of Cognito Detect. You can see a very simple scatter graph with 2 dimensions of certainty and threat. Remember, I talked about the risk scoring capabilities we have. Each circle, each dot on this matrix is a host that has a threat certainty score. So on this system, we might be monitoring hundreds of thousands of hosts across this large enterprise, but we're only going to show you the hosts that have got a threat certainty score. And if you have a high threat and a high certainty score, you're going to be in the top right-hand corner, right? So there's the critical quadrant. And I could click down on any of those machines. In the screenshot here, you can see a host J, when it was last seen, its threat certainty score, and the last detections. And very, very simply, I could click on that. I could drill down and look at the explicit threat detections. Cognito's going to tell me, okay, this is why I fired. Oh, do you want to see a copy of the packets associated with that? I've kept a copy. And where we go. So what this is doing is dramatically, shortcutting the time it takes me to look and identify the high-risk hosts and where I need to focus my attention, not just trying to sift through, a tsunami of alerts from my tooling. And then once I've found something of interest, I can then pivot out to Recall, okay, which is our forensic threat hunting tool, to go off and look for anyone else involved with that. So let's say we find, detectors found a threat here, and it was using a web browser to pop a PowerShell and then define a new Windows Log Manager service, and away it goes. We could then look for that particular surface definition and starting over RPC across the whole of the network using Recall. So Detect finds me the first instance, gives me the heads up and the context, and then Recall gives me the whole of my network history to go hunting with. Now, earlier in this presentation, I talked about AI augmenting and helping us, not replacing us. But there is a level of automation, not just in the detection, but that we can build into your security processes and workflows as well. Because it's software, it has an API. Because it's software, we can build integrations with other platforms to help you get even more out of your organization's security investments. So we can have Cognito send alerts to your SIEM. Well, SIEM get alerts already. But imagine a brute force attack. A brute force attack might look like 600 log files saying failed login, failed login, failed login, right? As we try different passwords. Cognito is going to send you one, saying, you've got a brute force attack. It's on this machine. Here's the evidence. Boom, straight away. So giving you that context. So we can feed into SIEMs. We can have it open a ticket inside your incident response platform, for workflows. We can run in virtualized or cloud environments, and that's really important because in increasingly hybrid cloud organizations, the attack may start local and then pivot out to the cloud. You need visibility across all of that. We'll actually integrate with endpoint devices which give us even more context. So let's say you had CrowdStrike or Carbon Black running on your endpoints. We see an attack going on the machine. We could even pivot to the machine and look at the process ID and see what's going, maybe even kill the process. And of course, we could even talk out to the network infrastructure. And here, I think we have to be judicious and we have to take a risk-based approach about where we automate remediation actions. For instance, it's pretty simple to have Cognito spot ransomware and then talk to your network infrastructure and say, hey, isolate that host. Now, isolating a single host is unlikely to do material damage to your organization. And for fast-moving threats like ransomware, which can propagate at scary speeds, I think it's probably rational to automate. If I've got a ransomware detection with a high threat certainty score, just isolate the host till you've had a chance to look at it. So that might be, moving it into some kind of remediation VLAN. It may be, just taking it off the network full stop, turning the switch port off, whatever. So I think there's a level here of autonomy and automation that can be done even in the responses. But I think, it's still important for the human to bring their own organizational context and learning to the situation. So let's say we see command and control information going out across the internet. If that's being tunneled through HTTPS, right, you probably don't want to block HTTPS automatically, right, because you're going to do harm to legitimate services as well. So whilst it would be technically possible to automate all of that, I think it's prudent still to have the human being in the decision loop and then just automate the technical steps that have to happen. So again, this is not AI taking over, just running your whole security stack. Human is at the very heart of this, the organizational context. But what it is doing is it allows us to dramatically automate and save time through it. So what kind of things do we find? So here's some examples, and we've classified them 3 different colors. The reds are fast-moving attacks. They're probably more opportunistic. They're not targeted. So here it's botnets, it's ransomware, it's crypto mining and things like that. We'll find things that are not necessarily attacks, but could be compliance issues. I know of a bank where we have Vectra Cognito in, and they spotted unauthorized firmware updates on their ATM machines. Now, it was a legitimate service engineer, but it was not an authorized upgrade. That's a massive compliance issue for them. Okay, for spotting a rat that was, pulling unencrypted personal identifiable, patient information out of a US healthcare provider. That's a massive compliance issue with the Healthcare Information Privacy Act, HIPAA, over in the US. But perhaps the most important thing that I think we do is find those low and slow, those hard to find, advanced, persistent threats, those targeted attacks, because those are the ones that do irreparable harm to your organization. And we found, lots of examples of that. Hidden tunnels in China that were attacking a US law firm and bringing out critical merger and acquisition documents. Now, that's an example of a supply chain risk, right? Maybe the big corporate has really robust security and it's hard to get in, right? Maybe the smaller law firm has a little softer underbelly. We go in that way. Maybe it's a foreign national or even a nation state looking to get commercial advantage in state-run organizations' commercial bidding. So we can use AI to find the botnets, the ransomware, the noise of the dirt that's out there in the internet. But perhaps the hardest job and most valuable job it does is find those really stealthy, low and slow attacks that would traditionally have to be manually threat hunted. So hopefully that's interesting to you. But so what? What's it going to do for me? Well, what we have here is some numbers from a 30-day trial of Cognito inside a European enterprise. They had about 200,000 hosts, so, a very sizable network. And over that 30-day trial, we observed, almost 200,000 hosts. We saw 29, almost 30,000 security events being flagged. Now, what Cognito did is correlate those individual events down to 1,249 detections, which were associated with 675 hosts, of which only 63 made it into the high severity quadrant. So if you're a security analyst, you might be trying to deal with, in this scenario, 30,000 alerts, 30,000 alerts. You just can't get through them all, right? And you go, oh, you know, the AI has dramatically shrunk down, you know, reduced the noise and give me the really salient information. It's separated the very weak, hard to find, but high fidelity signal that's hiding inside your network communications and surfaced it for you so you can spot it. And out of those 63 hosts, we found a red team exercise. So unbeknownst to us during this evaluation, the customer, quite cleverly, I think, had engaged a third-party red teaming attack, you know, to test their security posture. And this is what Cognito found in there. He found the red team host as part of that. So hopefully, you know, you've learned a little bit about the different dimensions to AI and how Vectra have thought about it and applied a very diverse set of AI techniques and machine learning techniques in the pursuit of threat hunting and threat detection. You know, I want to leave you just with a couple of thoughts about, you know, thinking, you know, are there opportunities for AI to help you? So, you know, the first thing to think about, I think, is around your security team's performance. You know, how many analysts do you have? Is it hard to retain and retire? You know, are there opportunities to help those analysts get more productive by taking some of the weight of the more monotonous, hard to do, slow, triaging of alerts? Yeah, actually, how many security alerts are you handling today? And how long is it taking you to work through them, to triage them, to decide it's a false positive, or to decide I really need to do something with this? You know, have you even begun to get proactive in hunting for threats in your networks? And then a more technical, you know, consideration might be, how would you even know? How would you today be able to find and know there was an attacker inside your network? Do you even have visibility? And remember, attackers are not just sat in China and, you know, or Russia or North Korea. Yeah, the attacker may be inside. It may be an insider threat as well. Right? You need to recognize that you don't have management control of all the devices on there. And what if you had legitimate services being used for illegitimate goals? How would you find that as well? So there's a kind of, you know, place that AI helps you with a, you know, human security team performance, but it also helps with that technical detection gap as well. So AI is going to touch everything we do in our lives, you know, from autonomous vehicles to, you know, smartphones, and it's going to be a big part of cybersecurity tooling and practice in the future. It's incumbent upon us all to skill up and be ready to be able to critically evaluate and know when and where to deploy it to best value. So I want to leave you just to signpost a few other resources that, if you're interested in finding out more about AI in the application of cybersecurity. The first is a blog from one of our lead data scientists, Shorb. Shorb's a postdoctoral researcher in neural networks, and he's written a fantastic, it's vendor agnostic as much as any vendor content would be, series about AI, and it takes you through the fundamentals to a much greater depth than I've managed to do in a couple of slides at the start today about AI, its history, you know, the differences, the hows and whys and whens of it, and also gets into topics like adversarial networks, how the bad guys are going to use AI in the future as well. Great video from Info Security Europe this June, was presented by my colleague Chris Morales. He looks at machine learning fundamentals for cybersecurity. So if you're a watcher compared to a reader, click on the video link in there. And if you do want something you can read at your own pace, there's a white paper around the data science behind our threat detection models. Now, if what you've heard today has piqued your interest, what can you do next? Well, I would suggest you get in touch with Bytes, arrange a 45-minute web demo or on-site meeting where Bytes and Vectra can come in and show you this technology live, and also have a discussion with you to see if we can surface some use cases for your specific organization. By all means, talk or, you know, read the experiences of others that are using AI today. Of course, as a vendor, we've got our own customer case studies, but perhaps with even more powerful of what organizations are telling Gartner about their experience of working with Vectra. So Gartner run a program called Peer Insight Reviews. It's free of charge on the web, and you can see Gartner verified customer insights. And really, this is your peers telling you about their experience and their recommendations. So have a look at that. And of course, we're very proud to receive awards and recognition. Most recent one in the UK was the Network Security Award, and we picked up an award with a medical customer called Mediclinic, and they got Project of the Year. They deployed AI into their security operations center and dramatically reduced the amount of noise their analysts had, and more importantly, the response time they have. And if you get to a point where you really want to see this stuff in action inside your organization, we can offer you a complimentary 60-day trial. We come in and do what we call a proof of value. We'll set some criteria with you. We'll deploy it. It takes about 30 minutes. It's really not a technically arduous deployment. You just simply need to feed us a copy of the packets off the network, off a spam port, off a tap, or off a network packet broker, and you'll use it. Cognito will work with you, and we'll be on over your shoulder probably 4 times during that evaluation to just have a look at what you found, give you some information and help, just so you can use Cognito and feel how it can help you in your security processes. And then we do a final end of proof of concept report. So with that, thank you very, very much for your attention. If we've got time, we can do some Q&A.
Thanks very much, Matt. Thanks for that really detailed insight into different ways that artificial intelligence can be applied. So I just want to invite the audience, if they have any questions on any of the aspects that Matt has presented, anything that they'd like to dig a little bit into in a bit more detail, or just specific questions regarding what about this, what about that, please do post them via the questions box or the chat box. I will be online for the next minute or so to monitor for those. Whilst you do so, if I can just take the time to thank you all for your, for taking the time out of your very busy schedules to attend today's webinar. I do appreciate that you all have very busy roles, and we do appreciate you taking 40 minutes and 45 minutes of your time in order to look at new and emerging technology with us. So I haven't had any further questions come in just now. If anyone has any more sensitive questions or one-to-one questions, please do drop them to myself, and I will feed them to the Bytes team and the Vectra team directly. Be delighted to do so. I'm just going to thank Chris again for his presentation, and thank you all for your time, and wrap up today's session. Many thanks and good morning.